Hi everyone. Okay, now I'm going to go over section 1.2. Built-in mathematical functions, numerics, and arithmetic in R. So in R, a numeric data type is one of the primary types. So integers, real numbers, floating point included. So floating point means it has a decimal or a fraction, whereas integers are whole numbers. We can check the type of data in R with using this type of function and then inputting the number. So even if we had a variable, we could put it in here. We don't have to put in the number directly. Similarly, numeric is very useful if we want to just print out a Boolean. This is called a Boolean. So this is another data type, true or false. It will just print out true if it is numeric and false if it is not. So if it is an integer or real number, we can print out yes or no, basically by outputting true or false. And here's kind of a little summary of the arithmetic operations: addition, subtraction, multiplication, division. We can do the power in two different ways. Modulus, as we'll see, some examples, we can divide one number by the other, and the modulus will give us the remainder of one number divided by the other. Whereas integer division is kind of the opposite, because when we divide one number by another, we get the output without the remainder. So you can see if 5 divided by 3 with integer division is done, we just get 1 instead of a fraction or a floating point number. And built-in functions for math. These are going to be very important. Absolute value, the square root, log, trigonometric functions, rounding. We can put in the number and then how many decimal places we want to round it to. Ceiling, round up. Floor, round down. Max and min, find the maximum and minimum of different inputs. The sum, the mean, so the average. So when we work with vectors, we can also, like I said, apply these functions to the entire vector at once. We don't have to apply it to an individual element of the vector. So when I say element of a vector, I'm just referring to one number in it. So if we were to run this, we would see if we multiplied the vector times 2, we would get 2, 4, and 6 as output, because 1 is multiplied by 2, 2 is multiplied by 2, and then 3 is multiplied by 2. Similarly, if we apply the square root built-in function to this vector, we would get the square root of 1, the square root of 2 here, and the square root of 3. So we can apply it to all the elements in the vector at once. And if we sum the vector, it's going to sum all of the elements within that vector. As we'll see, we'll be able to add two vectors element-wise as well. So basic arithmetic. So you can run this code block and see lots of examples of these math arithmetic operations: add, subtract, division, multiply, and they'll be saved to that variable and then printed. So we can see what operation we applied and what the output will be with each of these subsequent print statements. Built-in functions. These are some more examples: rounding, ceiling, flooring. You can see, for example, working with vectors, we can this is kind of what I was talking about before up there. So here we're actually running it. Sum 15, the square root. Okay, so section 1.3. I'm going to go over this in a separate video.